Now, in this section, we will delve into the different types of machine learning, specifically focusing on supervised learning, unsupervised learning, and reinforcement learning. This overview will help you understand these techniques and how can they be applied in various real-world scenarios. First of all, let us revisit the definition of machine learning. Machine learning is a subset of artificial intelligence that focuses on creating algorithms that allow computers to learn from and make decisions based on data. Instead of being explicitly programmed to perform a certain task, machine learning algorithms improve their performance through experience, much like humans do. There are three types of machine learning techniques: supervised, unsupervised, and reinforcement learning. Supervised learning involves label datasets in order to classify data or predict outcomes. Unsupervised learning involves training on algorithms that involve unlabeled data to discover patterns and structures. Reinforcement learning, on the other hand, learns through trial and error, receiving rewards for desired actions. Moving on to supervised learning. As we have already mentioned, supervised learning involves labeled data, which means each data point is tagged with the correct answer, and it uses that labeled examples to train the model in order to predict outcomes accurately. Moving on to the types of supervised learning techniques. The first type is classification, which is a very common application of supervised learning involving recognizing and grouping data into predefined categories. For instance, consider email spam detection. Here, the algorithm is trained on a dataset of emails along with a number of features, with the target variable being the label as spam or not spam. The model learns to identify the characteristics of spam emails and can then classify new emails accordingly. Another example is medical diagnosis. A model can be trained using historical patient data labeled with specific diseases. Once trained, the model can help doctors classify new patients' data, predict potential diagnosis. There's regression, which is another type of supervised learning technique involving predicting a continuous output variable based on a number of input features. For example, consider predicting house prices. A regression model can use features such as the size of the house, the number of bedrooms, and the location to estimate the price of the house. In the retail industry, regression models can predict sales figures based on various factors like seasonal trends, marketing campaigns, and economic indicators. Then there is support vector machines, which is another powerful tool which aims to find the optimal hyperplane to separate data into classes, often used in image classification. Then there is decision trees, which splits data into branches based on feature values. Example includes loan approval, where applicant data determines eligibility. A more robust version of decision trees involves random forest, which uses multiple decision trees to improve accuracy. Example includes customer segmentation by analyzing purchasing behavior. Another very popular technique is K nearest neighbors, which classifies data based on closest points, making it ideal for product recommendation scenarios based on user preferences. Another technique called naive Bayes involves a mathematical probability theorem named as Bayes' theorem, which is often used in text classification for categorizing documents. It is based on discrete events where the events are assumed to be independent, so the feature variables or the feature input variables are supposed to be independent. Linear regression and multiple linear regression, another subset of the regression techniques itself, involves predicting a continuous target variable as a linear function of multiple or a single input feature. Example includes stock price prediction. Another technique of supervised learning involves logistic regression, which can estimate the probability of a binary outcome, such as predicting the likelihood of a disease in patients. The next type of machine learning technique is unsupervised learning. Unlike supervised learning, unsupervised learning deals with unlabeled data, and the goal is to find hidden patterns or intrinsic structures in the input data. The types include clustering, which is a very popular technique that involves grouping similar data points together based on their features. For example, customer segmentation in marketing. Businesses can use customer data and group customers with similar buying behaviors, often called as market basket analysis. This helps in creating tailor-made marketing strategies to identify different customer segments. Another example of an application of clustering is image segmentation in computer vision, where an algorithm groups pixels in an image that are similar in color or intensity to identify objects within the image. Another type of unsupervised learning involves dimensionality reduction. It involves reducing the number of input variables in a dataset. This can help in visualizing high dimensional data or in improving the performance of machine learning algorithms by eliminating redundant features. Principal component analysis is a commonly used dimensionality reduction technique. It transforms the data into a new coordinate system, reducing the number of dimensions while preserving as much variability as possible. The applications include image compression to compress images while retaining important features, market basket analysis to identify groups of products purchased together. Final type of machine learning technique is reinforcement learning, which focuses on training an algorithm that follows the trial and error approach. This type of machine learning is actually inspired by behavioral psychology and involves training an agent to make a sequence of decisions by rewarding it for good actions and punishing it for bad ones. In reinforcement learning, an agent interacts with an environment, makes decisions to maximize cumulative rewards. Over time, the agent learns the optimal strategy to achieve its goals. A well-known application of reinforcement learning that you might have heard is in gameplay. For instance, Google's AlphaGo, which defeated the world champion Go player, used reinforcement learning to master the game. The algorithm learned by playing millions of games against itself, gradually improving its performance. Another example is in robotics. Robots can use reinforcement learning to learn how to navigate through complex environments, avoid obstacles, and perform tasks like picking and placing objects. Machine learning in totality has revolutionized many industries. It is used in vast variety of applications from fraud detection in banking and financial institutions, help potential frauds in algorithmic trading, in healthcare industry, to predict potential diseases and early diagnosis. In the entertainment industry, machine learning enhances our views and listening experiences. Examples include content recommendation systems on platforms like Netflix and Spotify. So, this was all about the overview of machine learning and its types, along with its applications. In the next in the next topic, we will dive deep into deep learning and a functional overview on how neural networks work. See you in the next section.